Alrighty. Well, thanks everyone for joining. Let's get started real quick on our talk about getting started with GitHub Actions for embedded. Real quick, my name's Joe. I'm family of 5, former John Deere, now leading Dojo 5, which was focused on firmware excellence. And we're passionate about building great cultures, high-performing teams. Dojo 5 is focused on modernizing firmware and firmware excellence. Dojo being, a place for immersive learning, and 5 being our foundation and family product and services company based in St. Paul. I am excited about all of these. We have a lot of lunch and learns that we've been putting together here, and this series of talks is all about things that I feel like are just tragically behind in embedded. Mobile and web guys have all kinds of mature unit testing tools, amazing debuggers, one-click DevOps, real-time monitoring, quick and reliable deployment, and then great CI tools. And I think embedded continues to lag behind, and it's ripe for, I think companies are, as they're starting to see more complexity driven into firmware and smarter devices, there's just a lot of opportunity for them to really capitalize on the technology that's out there that the mobile and web guys have already largely blazed the trail on, and just adapt it to embedded, and your teams can then move as quickly as mobile and web teams in a lot of cases, and kind of take all those lessons learned and just kind of like give superpowers to your team. That's really what gets me excited about this, and especially about the GitHub Actions today. So my assumptions today is that you know a little bit of the goals of CI, or what I mean by CI, being continuous integration. The whole idea is that instead of big bang integration, where we work on releases for days or weeks or months, instead and then do a big bang integration at the end, which largely fails, and then we need a couple more weeks to clean up the mess. Instead, integrating multiple times per day, adding tools and techniques to our toolkit to be able to enable this. And so that's those are all important assumptions that you kind of understand, like, and are along with me on that line of thinking. Also, that you know a little bit about CI terminology, and that continuous integration, kind of like you understand what I mean when I talk about that. So the plan today: GitHub Action concepts. We're going to talk a little bit about that, and we'll look at an example build. We'll talk about a couple of more advanced topics that you'll almost certainly run into if you're putting this in place for real. Secrets, concurrency, runners, marketplace, and then Q&A at the end. So GitHub Actions, what is it? Well, GitHub, of course, has been just a source code repository for quite a number of years. Recently got bought by Microsoft a couple of years ago. And so they had been really focused just on version control and just being really good at that, cloud-hosted version control. I think they saw the market moving and saw a couple of their competitors moving towards CI builds and automation to help their teams move more quickly. And they recently added GitHub Actions. All of the CI providers out there have their own little flavor of how these things work. And in GitHub, the way they've organized their thoughts are into something called workflows. So a workflow is like a top level recipe for how you're going to do some amount of automation. It's triggered by one or more events that can basically kick off the recipe. And then that triggers something called jobs. Jobs are an independent concurrent set of steps that kind of encapsulate like a particular kind of work stream. And the idea would be that you could have multiple jobs. Like, imagine like you've got a debug and a release configuration of your firmware, right? So you could have a job for the debug and a job for the release. And the concurrency is really kind of the big reason you want to split things into jobs, so that they can run independently. Or run concurrently, and then you can speed up your builds, because as you add more automation, you start to realize that there's a lot of opportunity to there's a lot of opportunity to spend a lot of time in your builds, and we'll learn that that's one of the resources that they limit and that they monitor and meter, and then want to charge you money for. So it's important to kind of be as frugal and as efficient as you can in your jobs. Then steps inside of jobs. Basically, each step represents some unit of execution. And really, there's kind of two main units of execution that you can choose from: actions and run commands. And run basically is running something from the shell. It's like something you type into either a Linux prompt or a Windows prompt or PowerShell prompt, something like that. Whereas an action is more of a packaged commands, and this is where some of the power of that GitHub's trying to bring to the table here, where you can actually create actions and then share them with others, and you can go to a marketplace and go use those actions that others have shared to help you automate your stuff more quickly. So that's kind of a nice kind of open source sharing community feel to it as well. A new concept that the other guys haven't really been able to do quite yet. So let's dig in a little bit. So workflows. Workflows, the high level is basically that they have to be located in a very specific directory location. .gitlab, so it starts with a period, that's intentional, and then workflows inside of that. And then inside of that directory, you can have as many YAML files as you want. And we'll talk a little bit about YAML in a second if you're not familiar with YAML. But that file houses kind of each of the top level recipes. There's one file for each top level recipe. You can have multiple workflows, and they can be triggered on a number of different things. I've got some examples there, and you're starting to kind of see what the YAML format looks like. But it can be either scheduled on the left there on a schedule, a cron job or cron format. If you're not familiar with that, that is saying like every minute when the seconds basically is equal to 0, run it. So you do it as often as that, or you can do it on a push, which is probably the most common one, as you see on the right. So whenever somebody pushes their code up to GitHub, then they would, get that. Or then your recipe would kick off and it would run a build. Also external hooks, things like other actions inside of the GitHub UI, like creating a PR or something, can also be attached to it. And then jobs. So jobs are part of the workflow YAML, and it organizes the work into units. As I mentioned, it's important from a concurrency standpoint for a large part. There are a couple keywords at the jobs level that I want to focus on. One is runs on, and this is kind of the environment that GitHub spins up to run this particular job on, and that's a required keyword. So you have to decide, is this at a job level, is this job going to be hosted on Mac OS? Is it going to be hosted on Ubuntu? Is it going to be hosted on Windows? Or something called self-hosted, which we'll get into later, which allows you to kind of run your own runner independently on your own hardware, which especially in embedded is a useful ability. And then there's also a needs keyword, and we'll look at that too. And that really is used to synchronize parallel builds. So let's say you've got an initial build that builds some common things, and then after the common stuff is built, then you can the artifacts from that or the output of that build is used for a couple of other steps. So you need them to kind of run in order in a more sequential way. Then that's what you'd use the needs keyword for. And then steps. So either action or run, as we mentioned, runs just build steps. Actions, you're able to share actions and Git provides some, but they basically encapsulate. It's almost like calling a function kind of. It has inputs, it has outputs, and the GitHub provides some. So those are actually, and things as simple as checkout or uploading artifacts, downloading artifacts for sequential type of builds. Those are all. There's a number of other ones that GitHub provides kind of out of the box that kind of the core majority of people need. So they provided. I got some links here to both the GitHub repo, the checkout repo, or action, and we can go look at that if we have time. And then just kind of the high level action repo where GitHub stores all of its repo or actions. So you can kind of look at those. And the last concept I want to kind of cover is Docker. I've had some other talks about covering Docker in more detail. Just high level, because we're going to be utilizing Docker in build environments as part of the automation CI. It's a lightweight VM. You may be familiar with VirtualBox or VMware. Helps you run like a full emulation of an x86 processor on your computer. Somewhat heavyweight. Like when if the computer you want to emulate needs 4 gigs or 8 gigs of RAM, it's going to fully allocate 4 or 8 gigs of RAM from your computer's total memory space. And so you can't have many of those running at the same time without a lot of RAM or a really beefy machine. The Docker folks kind of came up with a way to do a more lightweight version of VMs where things can kind of still run in isolation. They run in their own file system environment, but at the same time, they're much lighter weight, so you can run tens or even hundreds of these on a single machine at a time. And sometimes that's important for embedded, but also what's really important for embedded is just that reproducible build environment. They kind of encapsulate almost like a zip file that you can run as a build environment. So just a very useful tool, and we'll see where that comes into play in a bit. So here's, after all that concept, let's look quick at an example. It's an example off of some of GitHub's documentation. And this is, you can see that this is a workflow YAML file. And getting into the YAML details, I'll just say, if you haven't worked with YAML yet, the things you need to know, so there are keys and values. And so you'll see name and then greet everyone. That's name is the key, and then greet everyone's the value. And then in this case, on push. So in this case, they're using the brackets to basically say there's an array here, and we could have multiple triggers, but this is going to be triggered on push to the repository. And then you have jobs, and then there's hierarchy. And the big thing with YAML that I think everyone, their first couple of times using it, doesn't realize is that the spaces, the indentation and the number of spaces is super important. In fact, it will, like, you can see that there's exactly 2 spaces that the word build is indented. And in this case, that's, if it were 3 or if it were 1, you would get a YAML error. So it has to be exactly 2. And you can see the next level is exactly 2, and so on. But yep, so we've got our jobs top level keyword that just houses all the jobs. And then each job is itself a keyword here. You've got build, and then you've got a name. The job name is greeting. You've got a runs on, which is Ubuntu latest, and that's one of probably just a handful of runs on environments that GitHub supports. And then it has steps. And you can see that each of these steps, like the first step actually is an action-based step, and it uses the uses keyword. That's how you know. And you can see here there's actions, hello world JavaScript action v1. And this is one that GitHub provides. So GitHub owns the namespace that starts with actions. So any action that starts with action / that's a GitHub action. And you can see you give it you call out the name of the action, and you can even tag it at a particular tag. And the steps have names. And then in this case, with who to greet Mona, the Octocat, that's an input to the GitHub action. So actions, like I mentioned, are kind of like calling functions. They have inputs, they have outputs. And in this case, this one takes an input called who to greet. And it uses that. And really all this action does is just prints out, it just echoes out to the screen. And then, so the echoing is actually built in this action. And this action also has an output. And then you'll see that in the next step, we have a run action, run-based action. So it's just running a command line. And since we're runs on Ubuntu latest, we're giving it Linux commands here, but it's an echo command. And then this is how you access a number of different variables, and we'll see that too, but use the $ curly brace, and then there's a number of kind of variables that are available to you inside of this context. And so in this case, the output of the hello world JavaScript action is there's a time keyword in there. So steps, hello, outputs, steps coming from there. Hello is based on the ID that we've set over here on the step. And then the outputs is where all of the outputs of a particular action are stored. And then time is one that it outputs. So if we were to go look up the action documentation here for hello world JavaScript action v1, we would see the inputs and outputs documented. So that's how you know what the actions require. So let's look real quick at an embedded example now that we're kind of through the high level concepts. So the here's just kind of comparing this to what we saw before. We've got an example build. We're going to do an on push, and then we're going to run a build based on a container in this case. We didn't use a container before. Everything was just kind of being built locally. But in this case, I'm going to use a container that has Sager Embedded Studio, which is one of the IDEs you can use for Nordics stuff. And at Dojo 5, we do quite a bit of Nordic stuff. And we've got a particular SDK version called out here, a particular version of Embedded Studio. And so the nice thing about this is that we can just go to this container, and we know that all of our dev tools are set up correctly. We don't have to install any of that or get that all running for this, because every time you run this build, it's going to be starting with a kind of a blank slate of Ubuntu. And especially in embedded, there's often a lot of tools to install and stuff. So it's all been done for us in this container. And then we have some steps. We're going to have a run step where we run em build, which is the command line tool for Sager Embedded Studio. We'll point it at a Blinky app. And then we're going to store the artifacts. And you can see in that case, we're going to use an upload artifact action from GitHub. And it has an input parameter, and that's the path. And this will be the path, and it's not all listed there. I'll show you the whole thing, but that's the path where our output hex is going to be, and I'll show you how that works. So let's hop into GitHub. And let's see. So yeah, I'm going to create a new repository in GitHub. I'm going to make it private for now. I'm going to call it embedded. What do you want to call it? Embedded GitHub Actions. All right. So create a repository, and just like most repositories, when you create it, it's empty. But you'll see here's where Actions is, and here's where a lot of your Actions stuff happens. We can go into Actions right here, and it has a nice onboarding flow. You can choose some workflows. Of course, most of these are geared towards folks doing web and mobile development, and that's the whole reason why we're here, right? And so simple workflow, set up this workflow, or we can just set up a workflow yourself, and that's what we're going to do in this case. And so you see it does kind of get us going. It's created a file inside of .github workflows. It's calling it main.yaml. Sure, we can call it that. It's giving us some an ability to pull in some marketplace actions if we wanted to, and they've even got some rankings and stuff. This workflow has a name of CI. They're kind of suggesting on push to a particular branch or on a pull request to a particular branch. We kick this off. And then there's jobs, builds, running on Ubuntu latest. There's some steps. There's a checkout step, running at hello world, and then run a multi-line script. And you'll notice that in the YAML format, there's a couple things to notice here. When you have multiple steps, each step starts with a hyphen and a space. You notice that here there's a hyphen, a space, and then no hyphen space. So that's kind of just telling you that these two pieces go together. And then because you have a hyphen here, that's really representing, here's the last step. And then if you put out this pipe symbol here at the end, that's what lets you kind of do multiple commands in a way that's fairly readable on a run command. But yeah, if we just committed this, and I'm just going to kind of use the web tool for now to commit this stuff. Now we have something in GitHub workflows under main. And because we've got that there, we'll see that there is now a workflow that's been created. And so I went under to Actions and looked at all workflows, and here it is. You can also see that CI has been pulled out as the name of this workflow. So if you have multiple workflows, you can see them all running, or you can choose to see only a particular. This is kind of a way to filter it by that. You can see our workflow passed. We can see it completed in 22 seconds, and no artifacts, no annotations were created. And then if we go to the actual build step here, so this again is coming from our if you look in our workflow file, the name of the job was called build right here. So that's why this is called build over here as well. We could name it whatever we want. The setting up the job is part that GitHub just kind of runs behind the scenes. And then there's a run actions checkout. So that's checking out our code. In this case, we really had no actual code. And then it runs a one-line script, which is hello world, and then runs a multi-line script. And these names are again coming out of that example for all of these. And then post run actions is doing a checkout. And then we got to complete the job. So we finished everything up okay, so no big deal. Let's make this an embedded workflow. So I'm gonna just hop in here to easily edit the workflow file. And I'm gonna go grab, I'm just gonna ditch this for now, and I'm gonna grab the workflow file that we set up for ourselves. All right, and as I mentioned, we're doing an example build on push. We're running under Ubuntu. We're pulling down this container, which has all of our build tools for Segger Studio and Nordic set up for us. And then we're running one of the example projects called Blinky, just a Blinky app. And then storing artifacts. We're calling something called upload artifacts with a particular path. So we'll commit these changes. And then what we'll see under actions is, once again, we've kicked off a new build. It's queued. And while it runs, and once it starts, it'll be initialize containers. This is the probably the longest step once you start using containers. Obviously, we're saving a lot of time by installing Segger Studio, which is required for us to build. And having that already installed in Docker, in this Docker image. But it does add a little bit of time to the build because it is, in this case, large. And that's one of the, but I will say it's been optimized, and it could be a lot larger. That's one of the, I would say, kind of black arts of Docker and containers and controlling your CI system is trying to get these Docker images down to as small as possible, because it's just not efficient to schlep around a bunch of data. But yeah, in about 50 seconds, it's got everything down. Now it's going to begin running our build. In this case, it's a very simple build, so it happened very quickly. And storing the artifacts, stopping the containers, complete the job, and now we're done. Now we can go back to this build. We can see that there was actually an artifact. And an artifact, honestly, is just anything that your build tool wants to save, or that you want to save out of your build. In this case, inside of this artifact, if we look at the workflow file, I determined ahead of time that basically inside of this directory there's a hex file, an elf file, and I wanted to save those off, so they're available now as a zip file for QA to grab, or whoever whoever it may be for you to go, so you don't have to do a nice clean build. That this was done in a clean environment, sterile environment, and now you've got the artifacts zip that you can go grab. So that's kind of the most basic embedded example. Some kind of things that we can play with on this are the triggers, manual or scheduled. So if you want to make this a manual job, where like you just kick it off when you want to do it. Some people, either for QA reasons or other reasons, you can do it. You take out this push, you do and you can see that this editor has some support for filling in things. So on workflow dispatch, and that's all we need really. So then if we commit this, we'll see that a build will not be kicked off automatically. So no build, but we do have example build here, and what we can do is now we have a new button, run the workflow. And then we can choose which branch to run a workflow from if we want, and then we can run the workflow. And then at this point, it largely works the same. But this, you can see, like, Sometimes folks will have like a development releases that don't bump the version number in a like an initial build, and then when that just kind of runs continuously as people are checking in. But then when they're ready for like a production release, they have a special workflow that will bump the version number and then kick off like kind of a production release build, and maybe it strips debug symbols, and maybe it optimizes in a different way, some other things that we tend to do only for the production releases. So that's pretty straightforward. As we also mentioned earlier, there's a let me go on this way. It's easy to get to it here. But there's a scheduled way to kick these off. Yes, I did mean schedule, didn't I? And then you can say cron, and then you can say, yeah, like, every minute or whatever you want, and then it'll kick off builds. Now, again, jump into the end, but these builds will eat up your minutes, and you've only got so many minutes. So checking in something like that will chew up your minutes in not too long, especially if your build, in our case, our build is up to 1:15 right now. So it could, yeah, anyway, you just got to keep an eye on it so you don't use up all your minutes, especially if you want to use those free minutes that they give you. Should be great. And then artifacts. Not, I guess, too much more to say about artifacts other than what we already talked about, other than the way I find it best is to do these builds locally, and having a container definitely helps with that too, so that you can have the way it works locally is exactly how it will work on your device. And I can show that real quick. Let's see, time-wise, sure, we can do that. But yeah, if folks haven't done just local Docker builds, this is how you do it. You've got, hopefully that's big enough to see, but in here, I'm just gonna kind of follow along with what I'm doing in this, up here. I can run Docker run IT does an interactive terminal. And then we can run Joshny SES 350 SDK 1520, and then we got to tell it to drop us into a bash prompt. So now we're sitting inside of that terminal. You can see I'm on this Mac, but now I've got what looks like a Linux, backend. I can run SES bin em build, which is where our build tool is, and then tell it to run NRF SDK 1520, examples, peripheral, Blinky, and then there's a number of things here in the Nordic SDK that are driving us to the right based on what board we wanted to build it for and some other things. But yeah, so then here we are with the EM project file, which is the project we wanted. We're going to build the release config. And you can see that then runs, builds. And then now what we want to do is find our output. So I know from experience that the output will be sitting inside of a directory, but we can just kind of near our EM project file. But if we, so now, yeah, if we just try it in here, then we can be sure. So now in our output directory, we have a release directory, and then you can see that there are, a map file, a hex file, and elf file. And in this case, I just chose to grab all three of them with the star. But then this gives me the path that I can paste in here and be confident that it's going to work the first time when I run this. So, yeah. All right. So let's see. So I wanted to talk a little bit about secrets then. Along with CI, typically you want to store secrets in your, or you need secrets to access something. Oftentimes it's, you're accessing a backend, you're accessing, maybe it's a license for IAR, or maybe it's a password for AWS that you need to interact with during your build, or things like that. These secrets, yeah, make sure you don't check them in. There are plenty of examples of people accidentally checking in Amazon. Like Amazon tokens are a big one, but other passwords and whatever that then people, especially if you accidentally make your repo public, it just takes minutes, and somebody will scan your repo and find that password, and boom, you've got a Bitcoin miner on Amazon that you never wanted, and you've got a big bill coming to you in a month. So the way that you handle secrets in GitHub is this. You've got, for your project, you've got settings, and then you can go to secrets here, and you can create a new secret. And this will be, think of this like an environment variable. So this could be like super secret key, and then, I don't know, you give it, whatever your super secret key is, right? And you add a secret, that's the last time you'll be able to get it here. And even if I come back here, I'm not able to retrieve it. It's just stored kind of securely in GitHub's backend. And now if I edit this workflow, let's say that I needed to set an environment variable or something, like run a command here that yeah, maybe we just want to like this is a bad idea, don't echo your secrets, but you can do this, and the way you access it is super secret key. I mean, really what you'd probably be doing is doing some kind of like, deploy script with, key is set to, super secret key or something, but, for purposes of demo, do this. And now we got another step that has super secret key in it from our secrets. And now we can, oh, and we're still on the schedule, so let me do it on push. And there's our build kicking off. And we will see that, yeah, we'll see that once it gets to it. But yeah, that's where you want to keep anything that's secret. There's just knowing that it's there, knowing not to check it in, knowing to do it that way is a useful way to handle those secrets. Most of the CI systems do that. Concurrency is pretty simple with this. You just add new jobs and you use the needs to synchronize your steps. Once this is done, I would love to kind of show you the concurrency. Actually, we don't need to wait. We'll come back to that and show off the secrets. Add the workflow file again. And so yeah, let's say that I'm going to take out the secret key, and I'm going to say, like, let's say that so here we're building the release config. A very common item is you want to build the debug config too. So what I would do is rename this as build release, have a second job that's called, it's called build debug. And largely the same, otherwise, except that this guy is going to say to build debug. And then when we upload the artifacts, those end up in a different spot. And since we haven't defined any needs relationships here, it will be able to run those in parallel. And actually, let's go back and look at our secret. So you can see that there's actually 2 queued jobs. And we'll see if they actually run in parallel, but they're queued up. One completed job here. And you can see, like, here's our echo, and look, it actually figured out that we were trying to spit out something that we definitely didn't want to. And so it actually protected us from echoing that out. But inside of the script, if we would have like echoed it into a text file or something, we would have seen the actual value. So it knows the actual value, but it's trying to protect you in any way possible, from revealing this secret. So it's quite smart that way. All right, so let's see, 2 jobs in progress. You can see that now what's happening is we've got both of these jobs happening in parallel. It's initializing the containers. You do burn double the minutes when you do this, so just be aware of that. But now, we're not going to have to wait 2 minutes for this build to be done. We'll need to largely wait roughly the same time that we did before, because we're running these in parallel. And you can see build debug has already finished. Now build release is finished, and now the build is complete, and we have an artifact. Those are the artifacts from both of the builds, and we can actually see to breakdown. We were running on Ubuntu. Yeah, they roughly took the same time. There's a little bit of variability depending on network traffic and stuff, especially when we're pulling down the container. But yeah, roughly a minute a piece, and then you got all the artifacts here. Or if you go down to these, then you can grab the, I thought maybe, here we go. Yeah, this is what I'm looking for. So you can grab the artifact pieces here too. So each of these have a single artifact. Yep, and then there's a group of them up here. So, all right. So yeah, that kind of shows off quickly concurrency and how that works. I mentioned if you needed to synchronize the steps, if you needed them to go in order, or you had something kind of that was like a wrap up step, you could add another like all done step, and then you can put needs build debug, build release. And it also needs a runs on Ubuntu latest. And then we can give it for steps, we could give it a run step that says echo all done. Oh, of course, we could do something more interesting. But yeah, we'll let that one run. Each of these examples takes just a little bit of time to run, but yeah, that one will. Basically, there's a build release, build debug that are both queued, and it has not yet queued the 3rd job, which is all done, because it's waiting for the results of build release and build debug. And we'll be able to see that in about a minute. All right, so runners. There are a couple of different types of runners. There's self-hosted runners, which are sometimes a necessity for embedded and hill testing and some other reasons why it may be licensing issues where we need to have a local machine that has certain tools on it, like Coverity or Clockwork or some of the bigger like static analysis tools. Sometimes you have a network attached license that needs to be running locally. Cloud runners are what we've been using all the time. So this is like the machine that's actually running the builds. Self-hosted, or you can also think of this as on-prem. That's it allows you to run these runners locally. To set those up, I was hoping this would be done, but it's not quite done yet. How close are we? There we go. Build debug just wrapped up. That's funny. The debug one seems like it's getting done a little faster. Maybe optimizations. And now you can see now that those are both done, now all done is kicking off. And now he's queued up. He'll run at some point, and then he'll say we're all done, and we're good to go. That only took 1 second. So yeah. Let's say we wanted to run some of this locally on my machine here. If we go to Actions, and we want to do self-hosted runners, we can say we want to add a runner, and we can say Mac OS, we can say Linux. I'm going to say Mac OS. Create a folder, actions runner, extract the runner. So let's do that real quick. Just pulling up a terminal here. All right. All right, so we can we'll just put it in here. We're in GitHub Actions. We'll grab this curl command. It'll grab the GitHub Actions runner for OS X. You can see that there's, and then we'll untar it. We'll configure it, and it's given us our token right there. GitHub Actions, authenticating, so it's connected to GitHub. Enter the name of the runner. I'm just going to say it's my MacBook Pro. It will have the following labels: self-hosted, macOS, and x64. That's just fine. You can label it as like Hill Runner or something if you need to like make like if this is a special runner that only certain jobs can run on, you'll want to add another one. Work folder is _work, and we're done, and it's running. So then, or it's not running. Now we go run sh. Connected to GitHub, listening for jobs. So it's pretty easy to set that up. If we go back now to actions, we'll see it sees our runner. Here are the labels that are on it, and it's idle. If we then go to actions, and we're gonna, so the trick here is that this is running on Mac OS, and so it is unable to do a few things, one of which is Docker. So if we were to do one of these builds and try to run it on Mac OS, we would have trouble there. But let's just make a quick starter workflow that will run on this. And sure, we'll call it self-hosted test. We'll just do on push. And let's see, there's a lot of junk in here in the initial one. Our job, all it's going to do, and so in this case, we're going to go self-hosted here. So runs on self-hosted, and that's what tells it, don't run it on the back end with GitHub. Run it on my one of my boxes. And then our steps, I think those can remain largely the same. You run a one-line script, yeah, run a multi-line script. So we'll commit this, commit new file. And now under actions, we'll see that we have self-hosted test, and it's kicked off a build. And what we should see in here, yep. So now it's the job ran and it completed very, very quickly, right? And so we actually have run that. So it actually ran locally on my machine rather than out on the cloud. So obviously, if I had like a debugger or special hardware attached to my machine, then that's what it would allow us to run some of those kind of more embedded type of applications. But pretty quick to set up. And then the action marketplace. I just wanted to kind of mention, we haven't really dug into the actions too much, and that's probably not enough time to dig into them a ton, but there is this actions marketplace, and the actions marketplace is basically a lot of people, both GitHub as well as others that have created kind of like these functions basically that you can share, and a lot of them again focused on not embedded, but some of them are. Here's an action for ESP8266 I thought we could dig into. So when you choose one of these actions, you'll see this. You'll see an example of how to use it. In this case, you run it on Ubuntu, and it has, and basically you just say uses, and it doesn't look like it has any inputs or outputs. So that's kind of interesting. Let's go look at the links over here, and we can actually go look at the source. And all of the actions are actually just other GitHub repos. There's typically an action YAML at the top level. And this action, build your firmware directly in GitHub. So, you know, branding, color, blue, icon, there's some stuff. But the meat of it here is that this person has specified that there is a Docker image called ESP8266 RTOS SDK33, and it has arguments inputs, and it has an argument called make arg. And so if we can, there's a number of ways we can go through this. We can, so this is actually building, I think, his Docker file. So this is a Docker file that's running this, or going and grabbing the ESP32 IDF build environment, ESP build environment, and then yeah, downloading the tool chain, and so that this environment is then available for them. So yeah, I mean, this particular item, I mean, honestly, I wish there was more that came up when I went to the marketplace and searched for firmware. But there is barely anything, right? So here's another one, name, build, uses, and that's his action. We can look at his particular guy. Again, it's largely, it looks like it's building a Docker file. And then inside the Docker file, he's running his entry point sh, and entry point sh is running IDF build. And that's how you typically build IDF projects. So, yep. So yeah, there's a lot of opportunity here to, I think, innovate as far as embedded and GitHub Actions, but they're pretty quick to get up and running with. I would say there are a few limitations. One is that it's difficult to build on images from private repositories. And so, like, if you've got Docker images that are kind of proprietary to your company or that you're keeping locally, there isn't a great way to work around that right now that I'm aware of. I think, well, there are a couple workarounds, but it's not straightforward. You get the 2,000 minutes a month on a free plan, which can be limiting at times. Although if you run on your own infrastructure, then you don't get dinged for those minutes. So that's a benefit of self-hosting. And then I'd say also just watch out for security issues. Like I showed you, it tries to do its best at masking those secrets if you accidentally expose them in the logs. But you know, even running other people's actions, if their action is trying to do something like, you know, like copy all your source code and then send it off to some, you know, like S3 bucket that they have access to, they could exfiltrate your code very easily that way. So just be careful. That's definitely a little bit of a wild west on this, especially with sharing actions like they're doing. Like you could have malicious actions that do kind of bad things. So watch out for that. Otherwise, happy to take any questions if anyone has any. I think yeah, and if nobody has questions, I think thank you all for your time. Really appreciate the ability to talk with you, and thanks so much.